In FPS games, you move the desktop around a fixed cursor. It's in the graphic implementation of the game, but at the highest levels, FPSs are mechanically the same as clicking an icon on a computer desktop when it comes to aiming and shooting.
Wait, really? What?
Well, the mouse...
Hello everybody, welcome. I'm Ziggy, you're watching TheSigiBot, and this is Vtuber Reacts to, a series where together we watch clips, compilations, and all sorts of random stuff together. If you wanna me react to something, let me know in the comment section below. And now, let's enjoy the video. Let's go! Hi guys! So, welcome to another episode of Vtuber Reacts to. And today is a little bit of a different episode, which is I'm excited about. We're gonna be watching Ultimate FPS Controller Design and Build, as usual. The link to the original video is down in the description box below. If you have any other videos to me to react to, let me know in the comment section down below. So, this interesting video popped up on my For You page with this picture, and I was like, maybe we should react it together to it. So, without further ado, let's check it out.
Hey, Charlie Pyatt here. This episode I'm making a custom controller specially designed for first-person shooter games.
That's
I've been
interesting.
into making custom controllers and input devices for computers since I was a kid, so I'm really looking forward to digging into this project. The main goal of this build is going to be to combine a trackball with a gamepad to get the benefits of mouse aiming with the compact form factor of a console controller.
Okay.
The mouse keyboard versus gamepad control debate has been around for decades, but I think
that's
it's
true,
commonly
that's true,
agreed at
that's
this
true.
point that mouse aiming offers a competitive advantage over aiming with an analog stick in first-person shooters.
True.
What gets talked about less is why this is the case. I have an example here of using both a mouse and gamepad analog stick to move
I had
a
to make
cursor on a
this
computer desktop.
experiment myself too when I tried out my FPS controller to use as a mouse. It was a little bit slower.
An analog stick is more difficult. You have to anticipate cursor acceleration and deceleration as you move the stick in the direction you are trying to move the cursor. It's way easier to over or undershoot a target, and it takes more practice and concentration to get right.
There are some attachments to the controller available.
Desktop, you're moving the pointer around a fixed screen. In FPS games, you move the desktop around a fixed cursor. It's in the graphic implementation of the game, but at the highest levels, FPSs are mechanically the same as clicking an icon on a computer desktop when it comes to aiming and shooting.
Wait, really? What?
While the mouse may offer better aiming, it's really unable to handle sustained movement. To get around this, FPS games on the PC use the keyboard for movement, but that isn't a perfect answer either. Movement with a keyboard is limited to only 8 possible directions using combinations of the AWS
This is what I told in my Holocure or any hard survival games, that it's easier to play these types of games with a 360-degree movement.
You just push the stick in the direction you want to go. The further you push the stick, the faster you go in that direction. With a simple analog stick input, you can get much higher precision movement and speed controls in a much more intuitive package. So this is why I wanted to explore making a controller that combines the best aspects of a mouse and a gamepad by combining a trackball for aiming and an analog stick for movement together.
I'm interested how it works.
The concept of combining a trackball with an analog stick isn't a new idea. Valve explored a bunch of these concepts back in 2013 when they were developing their Steam controller.
What is this red
There's
thing?
a really interesting promo shot that shows the prototype development process and how many design concepts were explored.
Holy shit, that's a lot.
They went with dual touchpads for inputs over the trackball concepts. Going back even further, I found this research paper from 2010 that explores a similar concept of combining a traditional gamepad with a trackball as well.
Okay.
So I guess my question is,
so it's not a new question.
If integrating a trackball into a gamepad is such a great control scheme, then why doesn't this product exist? I'm honestly not sure, and that's what I want to find out.
Maybe it's difficult to realize.
For myself.
I assume it's difficult to realize, and maybe
this project is going to be
not really
out what the exact inputs
the greatest way to do it.
Design.
Ergonomic wise.
I want to maintain the functionality of a normal gamepad, so I'm going to keep pretty much everything intact as far as inputs go there.
Okay.
The big change is that I'm going to be removing the right analog stick because that functionality is going to be replaced by my new trackball. For the mouse inputs, I want to maintain the left and right mouse buttons, but will be removing any additional function buttons or switches.
It's kind of difficult to reach the Y, X, A, B buttons
is just so
if you
much
think
easier
about
with
it.
a simple mouse wheel, and something I always miss on console games. When I move all the elements onto the new controller, everything is roughly fitting into space. So now that I know the physical inputs I want, I need to dial in where they're going to be more precisely on a practical controller layout.
Okay. 3D printing.
Design process, I'm going to model in some placeholder input objects in Fusion 360 and 3D print them out.
Okay.
I just pulled the rough dimensions for these off an Xbox controller and mouse I had using calipers to roughen the shapes I need.
That's how you do it the most amount of time. Just do it roughly.
Which I can physically model into the controller shape I want. For sculpting, I'm basically just working the 3D printed buttons and components into a position that feels comfortable. As I worked on the shape, I realized I really wanted to have access to both the front and rear of the trackball. The idea being that I could move the trackball with either my thumb from the top or ring finger from the rear while holding the controller. This would let me do some fun moves with the controller once it's all built. I could operate the ABXY buttons at the same time I'm moving the trackball, do micro adjustments with both fingers to get better aim, or
okay, I see what he's planning to do.
To change the resistance of the motion.
Interesting.
These are all interesting options I really haven't seen done before, so I'm going to be incorporating them into the design for sure.
Maybe it's just cost-wise.
I just had to keep working the clay around until I got it into a comfortable position for my hands and all the inputs.
I guess the problem with this solution is it only fits his own hands, right?
Or doing any advanced detailing in the clay. This model was really about feeling right, with the surface looks not really mattering at the moment. With my clay model done, I started prepping it for scanning.
Ooh, even 3D scan.
I did 2 sets of scans, one with the controller oriented vertically on the turntable, and a second set of scans with the controller laying flat. I deleted the turntable from the scan data and then merged the point clouds together to generate my final mesh.
Huh.
The end results came out really nice, and this has more than enough resolution and detail for what I need out of this scan mesh. With my clay model scanned in, the bulk of the remaining digital work on this project is going to be creating a working CAD model of my controller for 3D printing. The steps in this project are to take in a scan mesh from my clay model, clean it up, convert it into surface geometry, and then make a precision engineered enclosure that will hold all my real-world physical components. For this project, I'm going to be using Rhino 3D for my mesh cleanup and surfacing. For the final product engineering, I will need a parametric 3D modeler that is better suited for dimensioning parts and managing components. For those parametric steps, I'll be using Fusion 360.
Okay.
So with my digital tool chain figured out, I'm going to start with my scan mesh pulled up in Rhino, and I'm going to do a bunch of operations to clean it up so I can start doing my surface creation.
That's a lot of work, by the way, for everyone who was wondering.
I 3D printed and placed them in their positions on the scan in Rhino. These will act as references for building the rest of the model in later steps. For the scan cleanup, I'm going to be using Grasshopper, which is a graphic programming language for Rhino. From here, I can bring in the buttons I placed in 3D space and subtract those from my scan to get just the body of the controller. After that, I run some smoothing operations using a voxel plugin called Dendro and convert the output to surfaces. This takes me from a pretty ugly scan mesh, which I have no easy way of editing, into a nice clean surface model for working on.
I agree.
Next up, I'm going to use the clean scan data to generate a network of NURB surface patches that will define the outer shell of the controller. Defining these NURB surfaces is
chunky, isn't it?
surface sculpting or Class A surfacing, and is a whole subdiscipline inside the 3D modeling for manufacturing world.
Child's toy.
At this point, I've worked over the surface patches and have a network I'm pretty happy with. If I turn on the zebra stripe view, I can see some minor warps happening, but I don't see any major jagged discontinuities going on or anything like that. Likewise, with the environmental map turned on, the reflections all look clean enough for what I'm going for. In the end, I'm going to be 3D printing, priming, and sanding all these parts, so I don't quite need to be as obsessive as I would if these were going into production tooling. And with that done, I'm pretty much wrapped with my Rhino work. From here, I can export all this as 3D step files that I'll later import into Fusion 360. Before I move on to the parametric CAD phase, I need to figure out how all the electronics in this are actually going to work. I want this to be a wired controller, so I don't have to package the battery in the device itself. Beyond that, I know I want this to be recognized as a standard Xbox controller and USB mouse on my PC. I also want to stick to repurposing off-the-shelf components for all the electronics as much as possible. With all that in mind, I'm going to order a
interesting if
third-party
it
Xbox controller and
will have
trackball
a
to continue my
functional
testing.
prototype at the
Got
end.
my controller and trackball in, but before I tear these down, I want to actually use them together and make sure everything works. I'm going to be using the AimLab's FPS trainer for all the testing going forward, so I need to verify this control scheme is supported before moving on. I'm using my Xbox controller for movement and trackball for aiming here in AimLabs, and everything seems to be functioning okay.
Interesting.
Now that I know my hardware will work for what I need, I can tear the trackball and gamepad down and start figuring out how to integrate their internals into my new controller form factor. Starting off with the trackball, the internals are looking straightforward and pretty good for what I'm trying to do. The main button and controller PCB is a little larger than I'd like, but the scroll wheel and trackball sensor are separated off the main board, which is really good. The scroll wheel is basically just a potentiometer connected by 3 wires. I can extend those wires to position the scroll wheel anywhere I want in my controller relative to the larger board.
So this is how they actually create prototypes. They get themselves already existing pieces, and it's like kit bashing in a sense. So without creating new PCBs, they make it out of already existing products. This is how usually product design works. This is a more complicated, I think.
As the trackball. The main PCB on this is very large and won't even come close to fitting inside my controller design.
Holy
Half
shit.
my controller space is also taken up by the actual trackball, so I can't have electronics that are anywhere near this size. I could try ordering additional controllers to see if they have smaller boards, but I'm pretty sure they would all be in a similar layout and form factor to what I have
here. So he probably will rebuild it completely.
My options on this one are pretty limited. The strategy I'm coming up with to get around this is to move the Xbox controller board to a breakout box and connect all the electronic components in my controller through a single multi-conductor cable. This will basically work like a bunch of extension wires coming off each contact on the Xbox controller board and going to a button in my custom controller. Once everything is done, I should have a single cable running between my controller and breakout box, and then a single USB cable that connects to the PC. When I plug the USB in my PC, I should see 2 devices, Xbox controller and the trackball.
People like it,
so I think I'm good to continue on through my design process.
It's smart.
It's a good time to put in some work on the industrial design of the product and establish the overall look and feel of the controller.
Yeah, let's do.
I can see the controller as being pretty standard on the left side, with the right side being pretty weird. I really want to ramp up the crazy on that right side, so I'm going to cantilever those side shoulder buttons off the controller as extended arms. I also want an independent element containing the trackball. This will help visually separate it from the surfacing scene on the rest of the gamepad.
That looks interesting.
As I did more sketching, I came up with a basic design theme where high contrast parts were holding in all the interaction elements. With an overall picture of the form I want to explore, I can move into Fusion 360 for my parametric CAD work. For this section, I'm going to be stepping through my parametric timeline in Fusion 360 to show my build process. I've got my surface design pulled in from Rhino. The buttons and trackball aren't integrated into the form at this point. My first step is to cut away a space for the trackball itself. Next, I blocked in the lower area that will house the trackball sensor. In the section view, I've added an internal bracket to hold the sensor. With that all roughed in, I'm going to move over to the trackball cradle. This is the actual element that will hold the trackball in place. It basically serves to isolate the trackball a specific distance from the optical sensor in the controller body.
I like it, man.
The plan from here is to have adjustable pins that go in and hold the trackball in that cradle. These pins are going to be set screws tipped with ceramic bearings and should allow me to make micro adjustments to the position and resistance of the trackball once it's all installed. So yeah, you can see the trackball holder isolated into its own separate body now.
That's interesting. That looks like the spider from Ghost in the Shell.
These will each work as their own sub-assemblies. In this design, I can load my tactile switches into this housing, then push the outer button down to seat it. They'll slide down onto this larger body that will be part of the outside of the controller. That'll prevent these clips from bending back out.
I hope they don't have too much play inside those stuff.
That's the kind of problem solving and design you have to do on each of these components.
Yeah.
Each part of the controller is its own little design and engineering challenge that you have to figure out and integrate back into the larger product.
Holy shit.
As I'm installing all my buttons, I'm constantly checking them against my original source model from Rhino. This is really important because it lets me see the difference between my digital model button placements here in Fusion and my real-world clay model button positions. Next up, I'm going to be building out the buttons on the left side of the controller. I'm modeling in my left shoulder and trigger buttons here. The trigger is going to be pretty unique. I kind of want it to swing down under the body of the controller. I'm just kind of cutting and sculpting it until I have a shape that looks good. With those buttons roughed in, I'm moving on to the top surface of the controller.
But this controller is gonna be heavy as heck, man.
To add these kind of tabs on the end of the directional pad. I like the idea of being able to swap those out for longer or shorter ones, depending on the performance characteristics you wanted out of the controller. Okay, so now we're moving on to the analog stick install. I've modeled that component out and built in a little bracket on the inside of that controller body.
This is fascinating, man. This is fascinating.
The actual analog stick hat for the outside of the controller. Up next, I'm going to get into those cantilever buttons on the right side of the controller. Inside each of the arms is a little recoil spring that will add resistance to the button pull. When you depress the button on the outside, the lever arm pivots around a center pin, and then this little internal hammer comes down on one of those mouse switches held in a bracket. So the way most controllers work is the buttons and switches are spread pretty evenly throughout the controller body. By having all my right shoulder buttons on cantilevered arms, I'm pushing all my switches to the left side of the controller. I'm basically forcing all of my electronics components into this little tiny area over here.
Yeah, that might be a problem.
Product designers and product engineers butt heads a lot of times. I still have to get my left shoulder and trigger button hooked up and running. Starting off with my left shoulder button, I'm shelling and drawing in a post that this button will pivot around. On the inside section view, you can see how this will clip into place on the main controller body. I should be able to just press this one in from the outside of the controller during assembly and it will snap right into place. Now that I have the left shoulder button installed, I need to do the left trigger. I can put the trigger on, then slide 2mm rod stock to lock it down. There's going to be a recoil spring that I actually pulled off my donor Xbox controller that goes in here. I still haven't hooked up the hardware for the left and right triggers yet. For that, I'm adding a cantilevered arm coming off the trigger. This assembly will twist a potentiometer that acts as an analog input for the trigger action. The potentiometer will press fit into this little
I'm excited to see the final product.
The right trigger arm will
I'm interested if he will have
another potentiometer.
Real life thing to present.
Moving on to the cable entry on the controller.
It looks insane.
My cable is actually going to be mounted on my trackball assembly.
Monstrosity, I love it.
Clamp to secure the cable as it passes into the controller. So yeah, this is kind of the home stretch here. The last step is to make a connection method for all these separate outside parts.
Yeah.
The outside shell is just kind of floating in 3D space right now. It needs to be linked together somehow.
Yeah.
This kind of all comes together like a complicated puzzle box. The parts need to be assembled in a specific sequence. Once they're all in place, they should keep each other locked together. So yeah, with that, we're all done. If I kick on my old reference model, you can see everything is pretty close to where it was in the clay model.
Yeah, that's
the important thing is that whenever I had to make a button placement change due to mechanics, I was able to check it against the physical clay model button position. This would let me know if that change would impact the ergonomics of the final design.
But still, that's just gonna be a pain.
It's time for 3D
pain,
printing.
dude.
For that, I'm going to export my objects as step files to Preform. Preform is the slicing program for my Form 3 SLA resin printer. I had to do these in several print batches, but the parts came out looking really good.
Ooh, yeah.
Each of the print batches goes through an IPA bath and then a final UV cure. With all those done, I have the bulk of my final printing run complete. I need to dry fit and test the entire controller to make
that's
sure
gonna
it actually
be. This
works
is one
before
important
final
part,
painting and
actually, one of the most important,
for that,
if not.
I'll need to do my wiring. If you remember back to my wiring strategy, I'm really just running extension lines off the Xbox PCB through a 24 conductor cable to the switches in my custom controller.
Dude.
I mapped out all the connection points I need on the Xbox PCB. These will run through a smaller terminal board that I can plug my DuPont connectors into.
Look at this.
With all my wiring done and checked, I can move on to my dry fit assembly and testing.
Okay, that's a...
Right, so you can see I've got my controller all dry fit together here. All the buttons are hooked up to the main wire harness and everything should be running. It's pretty awesome finally seeing this come together. I've got this hooked up to a control tester and you can see all the buttons running.
Wait, what?
So got A, B, X, Y, up, down, left, right, analog stick. and upper shoulders. Yeah, everything's going.
LOL.
The action on this really feels awesome. Like, I love these sort of extended controller arms here. It uses clicky switch from a mouse, which is way more satisfying than the membrane dome switches you find on a controller. Mouse wheel is running.
What? Yo!
That's awesome. So yeah, I basically have all the functionality
of
a mouse and a gamepad packed into one weird, super strange controller, which is exactly what I was trying to do. It's great. Oh, and I still have my old stick over here that works too. Nice. Yeah, this is amazing.
Insane.
Sort of baffled that this worked on the first try. Did some diagnostics and testing before, but really, yeah, all the boards, all the cabling, everything's worked. As long as I can figure out a way to
I'm in shock.
The enclosure, I should be good to go. But yeah, that's my one concern now is I've the DuPont connectors there taking up more space than expected. So we're going to see. It's going to be very tight in there, but I'm pretty sure this will all come together okay.
Holy shit.
Yeah, again, I just love these switches. They're just like the most satisfying thing ever. Really liking the trackball access on the back. This is just so radically weird to be able to move the trackball and then also control it from the other side. And I can spin really fast and make these massive adjustments and then make fine-tuned micro adjustments by sort of pinching it and just get this really nice control. It's really cool too because I can access the buttons and still be aiming around, which is super unique. So yeah, you can see right here, I'm still operating the mouse and yeah, also hitting buttons, which you can't do with the normal controller. The pin system I designed that allows me to adjust the strength of the resistance of the trackball is working fantastically. I can just do little quarter turns on these screws to really tighten or loosen the resistance of the trackball and just get it feeling exactly the way I want. I love the stage. It goes from just being something abstract on the computer to being in your hands. It's always a little scary. You don't really know how it's going to come together or work out, but man, this is amazing. Can't wait to move on. Next step is going to be to tear this back apart, paint, and then do a final reassembly. So we'll go from there. I have my parts broken back down for the painting and finishing step.
Wow.
I ended up using some rattle can finishing paints for both my priming and color coats on these. The detail level on these 3D printed parts is great, but it still requires priming layers and wet sanding before final painting. There are lots of parts that need to be finished here, but fortunately only the larger exterior pieces really need multiple priming passes. To build up my primer and sand it back down, I'm starting to get a really pristine surface on these final parts.
Nice.
For final finish, I'm going to leave the bulk of the parts as raw primer with a glossy clear coat. The small bright blue components will get a matte clear. I really like using different clear coats on different subcomponents. It adds a nice texture variance to the finished design and makes it look like a more complete product.
Ooh.
At this point, I'm really happy with the way the final parts are looking, so it's time
insane.
for the reassembly of everything.
Bro.
My final assembly steps go in almost the same sequence as the CAD build. I'm getting my trackball loaded into the cradle and making sure the action is working okay. Next up, I'm loading my dome switches into my ABXY buttons.
Okay.
Left tolerances to account for the paint buildup, but some of these need a light sanding to get them feeling right.
Yeah, tolerance is a problem.
I also added a very small amount of lithium grease on all my moving parts to get a smooth action on everything.
Nice. Good thinking. Look at this. Holy shit.
From there, I'm moving on to the left side of the controller.
Oh my
it's really
goodness.
nice having the two sides as separate parts. Makes loading in all the components and switches so much easier.
I wonder if he would have sticky drift though. Do you guys think? Let me know in the comment section below. I think he wouldn't
my left side components feel great, so now I need to load in the extension arms for the right shoulder buttons.
Remember, that says still 3D printed pieces, so they...
With those in place, I hook up the potentiometer for the right trigger and add in the button ends for those arms.
Be very durable.
Everything is feeling spot on, and I can really see the controller coming together. I'm plugging in all the DuPont connectors.
It would be dangerous to throw him away.
Checking to make sure all the plugs are going into the right pins. Next up, I'm securing the main cable into the controller to make sure there's no tension put on those inner wires.
Oh my gosh, so much work.
I'm piecing all the main parts together now. With a final little push, the two halves of the controller seat together and it's all done.
Oh!
The final bit is to mount everything into my breakout project box. And with that, the build is done. It's been pretty amazing taking this all the way from concept to finished design. Things took a lot of unexpected turns, but seeing it all done
he added this blue thingy. I want to see him in action. Show me in action. Show it in action, please. Still cannot quite imagine how it would work. It looks a little bit strange, but exciting actually. I love this idea with blue and cutting out space. It's interesting.
And with that, it's time for the fun stuff.
Yeah, let's go.
Play testing.
This is interesting. Let's go.
I'm going to be running my testing 3 separate times.
Okay.
Once with a normal gamepad, once with a mouse, and then with my custom controller. For each of these different control methods, I'm running 3 different scenarios in aim labs. Cluster aiming at targets close together, dynamic aiming at a moving target, and then spread aiming at dispersed targets.
Okay.
I started with spread target testing to kick things off. To be honest, I was really struggling with the new controller at first. If I increased the trackball sensitivity high enough to get good direction control, my precision aiming became way too twitchy and jerky. If I lowered the sensitivity to get better precision, then my direction changes were way too slow. Fortunately, I'd already been using an open source software called RawXL for the controller. RawXL lets me adjust the input curves for mouse aiming. This makes it so I can have a stable and precise crosshair while still being able to do quick turns with the trackball.
I see. So the adjustments, calibration is
really opened up the
difficult.
controller, and it started feeling super comfortable and intuitive to use. I logged my data doing 20 or so test sessions, pulled in the top 10 scores, and sorted them from worst to best. None of this is particularly great from a data science point of view, but it's sciencey enough for what I'm going for here. In spread aiming, the custom controller top 10 scores averaged about 85% of my mouse performance.
Oh.
My standard gamepad average score came in at only 61% of my mouse average. That difference was pretty sizable, but it was really amplified when I switched over to my fast cluster target training. This exercise requires really quick twitch aiming, rapidly switching between targets. My standard gamepad performance really fell off a cliff on this, bottoming out at only 37% of my mouse average.
Interesting.
Custom controller stayed constant here at around 84% of my mouse performance. In my final testing series, I had to maintain tracking on a moving target. In the performance numbers, the standard gamepad came in at a much more respectable 76% average against the mouse and keyboard. But I was generally shocked that I managed to put in a 93% comparable score with the custom controller. I feel like with the analog stick for movement, I was more accurately able to match the motion of the target, almost turning it into a stationary aiming exercise. This gave me an advantage using both the custom and stock controllers, ramping up their scores compared to using the keyboard for movement. So what does all this mean? Well, I've documented that I'm pretty bad at FPSs with a standard gamepad for sure. The custom controller was super interesting though. I have who knows how many hundreds of hours playing games with normal gamepads and mouse keyboard combos. I have probably 4 hours total playtime with the custom controller at this point. And despite that, I was able to put up competitive numbers with it, which is kind of crazy. There are also moments with the controller where it would just sort of click into place. I would look at something on the screen and just be able to hit it. Sort of like when you're learning a new sport or musical instrument. There are these moments where you can stop thinking about doing it and just do it. Definitely don't feel like I've hit my skill ceiling with the new controller yet, so it's going to be exciting to see how far I can push it forward. The thing that really struck me about this project is that good ideas are buried in the details. There have been a bunch of attempts to make trackball controllers over the past 30 years, but they were all abandoned for one reason or another. I think what really made my design work was finding the right ergonomics and aiming software with the trackball. Without hitting on those things, the performance would have been much worse and the new design just wouldn't have been fun to use. Turns out it's all about those details. The other bigger question I have about something like this is where it would fit into the market as a product. For consoles, you need industry adoption for something like this to work. That's why I feel like non-conventional controllers would struggle right now. Game developers and console manufacturers can balance crossplay between mouse and controller players because those two isolated control types have been perfected over decades. You throw something like this into the mix and all that balancing and playtesting gets messed up. That being said, the industry is changing. Those lines between predefined input schemes are going to continue to blur, and there's no way of stopping it. I do know that when I cast games from my PC to my living room TV, this controller becomes amazing. PC casting setups are still kind of a fringe thing today, but it's going to be more and more common in the future. And it's always nice when you get those little glimpses of the future. Thanks for watching, and see you next time.
Damn. That's so... what can I say? What can I say? Man, that's interesting. He touched on an interesting point. So in the end, especially, he said that the industries have standards in the console gaming. And he's kind of right. If you think about it, it's a wonderful idea. I never seen it before. And I think his solution is kind of interesting, combining two of... So from my humble little experience, I've never tried the trackball mouse. I don't know how well it works. But design-wise, I think it's interesting to have a cutout piece. Something that I not sure, maybe I didn't pay enough attention, but the analog stick not only have their movement, but if you press on them, they also count as an input. So was it taken away, or is it one of those triggers? Because on the left side, wait, maybe I can show it. Can you see my mouse? On this side, you have the mouse wheel, and then he has R1 and R2, or trigger, right trigger. But here he got 3, and I assume one of those buttons on the right side is a mouse function button, probably. So I'm wondering about that, because there are standards in console gaming. That's interesting, man. That's such an interesting topic to talk about. I would be interested to see how this controller would perform in games like real FPS, not aim lab, but FPS where you have to, like Titanfall, for example. Or how would this work in Call of Duty? Valorant is one of those games where you have to be fast with your decisions. Valorant, stuff like Overwatch, this is interesting. That is an interesting topic. Even though I don't think this might come in our future to see such a controller, because a lot of stuff that he made is difficult. Maybe there's something planned, but he mentioned also that the insides of a controller, right, are quite difficult to change. They have a form factor that is standardized. So who knows? But it's still an interesting idea. But anyways, let me know your opinion in the comment section below. As usual, link to the original video is down in the description box below. Please go and check this channel out. It is called Python Design. Interesting, completely new idea. And until then, thank you everybody for watching. I will see you all around. Have a good one. Bye bye. Ciao.